In this video, you will learn about regression analysis and how to model numerical outcomes based on the available input features in a training set. We'll explore how a regression tree model can be used to describe the relationship between an input feature X and outcome variable Y. Ready? Let's go. An overarching goal of regression analysis is to model numerical outcomes based on the available input features. For example, with a training set like this, a good model might be a piecewise regression model. In the first interval, every x produces y equal to 34.8. In the second interval, y equal to 32.2, and so on. A model like this is generated by the regression tree algorithm, where a constant value is fitted within each segment. This allows us to model both linear and nonlinear relationship between x and y without explicitly specifying a continuous mathematical function between them. To construct the regression tree model, we first split the training set into two subsets. We find the threshold S that best splits the input feature x into two segments. Within each segment M, the outcome variable y is modeled by the local mean value of y. The goal is to find the best boundary S that minimizes the total error. The error within each segment is calculated as the sum of Euclidean distances of all points to the mean value of y. The total error E is the sum of the errors in all segments. Any distinct value of x can be considered as a potential boundary. In this example, we found that the boundary 93.5 minimizes the total error among all possible boundary values, making it the root of the tree. We continue to grow the tree by finding another boundary within each of the segments in the same way as the previous split. This process continues until we reach one of the stopping criteria. We stop growing the tree if all points in a node have identical values for all input features x. We also stop if the split does not significantly reduce the total error or if the split produces a node smaller than the minimum node size. Limiting the minimum node size and the tree depth is important to avoid overfitting. Here is a resulting tree from our example, generated by the simple regression tree learner node in Knime Analytics platform. One advantage of a regression tree is the ease of interpretation. By following the splits on the regression tree, one can easily reach the predicted outcome. Finally, here are the resulting prediction rules based on the regression tree as we saw earlier. In this video, you have learned how to use regression trees to model numerical outcomes based on input features. Construct a regression tree by finding optimal splits to minimize the total error. Apply stopping criteria to avoid overfitting and interpret the results and prediction rules generated by a regression tree.